Second thing that we want to prove is this formula here, that A over sine A is equal to B over sine B is equal to C over sine C. We're going to do it for a triangle that has acute angles, and we're going to do it also for a triangle that has one obtuse angle. So we start off with our triangle. You can label your sides. I've done it the same way as it is in your book. And what we want to do straight away is we want to drop a perpendicular straight down, and we'll call this point here D. Now, what do we know? Now that we have some right angle triangles here, we know that the sine of A, now we need to label here that if this is the side A, this is the angle A. So that if we know this is sine of A is opposite over hypotenuse. So sine of A is equal to, let's just call it the side BD, all over, in this case, your hypotenuse, we call it C. And then what else do we know? We know if we look at this triangle here, this right angle triangle here, that the sine of C in this situation is equal to BD all over A. Now, I can move this around and know that BD is equal to C times sine A. So the top one here, I can just manipulate it and know that that's C times sine A. And similarly here, I know that BD, it's meant to be, and also BD here is equal to A times sine C. If that's equal to that and that's equal to that, well then that's equal to that. So we have A sine C is equal to C sine A. And then I can bring this over, so I end up with A all over sine A is equal to C all over sine C. Similarly, you could do the exact same thing by dropping a perpendicular from this. You know, I can turn my page around and drop a perpendicular from here down to here, and we'd include the angle B in the side B. So that's the first part of the proof, and that's exactly what's in your book. Okay. Now, in like manner, so I just said similarly, you could draw a perpendicular from C to AB, and you can prove that A over sine A is equal to B over sine B. Therefore, A over sine A is equal to B over sine B is equal to C over sine C. Okay. Now that's for your acute triangle. If we go back here and we look at the obtuse triangle, so the original triangle is again ABC. We drop a perpendicular down to, you know, we'll have to extend this line here, because if you drop a perpendicular down, it's not going to land inside your triangle like it did inside in the acute one. And again, we start looking at our triangles, and what do we know? We know that if we look at the angle A here, that the sine of A is equal to, now we're looking at the big triangle, it's BD over C, and the sine of C in this smaller triangle here is equal to BD over A. Again, I can look and see, okay, that BD over A is equal to, you know, we took this triangle here. So it's not actually the sine of C, this is C here, which means that this angle here is going to be 180 minus C. But the sine of 180 minus C is the same as the sine of C. Now, the reason for that is that, you know, sine is positive in your first and second quadrant. So if you're getting the sine of 30, that's the same as the sine of 150. If you're getting the sine of 40, that's the same as the sine of 140. So And when we look here, we have the opposite over the hypotenuse is equal to the sine of this angle here. But like I said, the sine of this angle here is equal to the sine of 180 minus it, which is just the sine of C. And then you can finish it off again. It's the exact same way to finish it off, and you'll prove it for both.